Before we do example 1, let's take a look at the trig identities in the box on the top. You do have to memorize these identities. You have to know them. And the better you know them, the easier things are going to be for this chapter. The first thing are the reciprocal identities, and these you already know. So there's not a whole lot of memorizing. You should already know them given chapter 4. So the reciprocal identities just tell you what the reciprocal functions are. So sine and cosecant are reciprocals. So sine is 1 over cosecant, whereas cosecant is 1 over sine. And it goes for cosine and secant are reciprocals, and tan and cotangent are reciprocals. Your quotient identities you already know as well. The tangent is the sine over the cosine, and cotangent is the cosine over the sine. The Pythagorean identities, we have 3 of them. Sine squared plus cosine squared is equal to 1. Tangent squared plus 1 equals secant squared. And cotangent squared plus 1 is equal to cosecant squared. Now, you can use these Pythagorean identities in all different sorts of ways. So it doesn't just have to be tangent squared theta plus 1. What you could do is you could subtract the 1 over to the other side and say, hey, tangent squared theta is equal to secant squared theta minus 1. And that's another identity. So we can subtract the 1 over and look at something like this. And that goes for all 3 of these. You can rearrange the sines and the cosines or the cotangents and the cosecants and the 1 and make different identities out of that. But if you memorize the first 3, then you can go ahead and do those manipulations later if you need to. Then we have our cofunction identities, and that says that the sine of theta is the same as the cosine of pi over 2 minus theta. Or you can think of this as 90 degrees minus theta. But in terms of radians, 90 and pi over 2 are the same. For instance, one that should make sense to you is the sine of 30 degrees is going to be the same as the cosine of 60 degrees, if you think of those 30, 60, 90 triangles. And then the odd and even identities, this tells us that the sine of a negative angle is going to be the opposite of the sine of theta. And that goes for the cosecant. So all you really need to do is memorize the top ones, and then the reciprocals are going to be the exact same way. So if the sine is that, the cosecant is also going to be that way. The only ones that are going to be positive is the cosine and the secant. And the reason for that is if you take a look, cosine, remember, is positive in the first quadrant and in the fourth quadrant. So if you think about an angle being rotated in the positive direction, you're going to be here, which gives you the cosine this positive x-axis. And if you're going in a negative direction, you're rotating this way, which gives you your triangle in the fourth quadrant, which again is still using that same positive part of that x-axis, which is why these two are going to be exactly the same, and the others are going to be the opposites. If you have questions on any of the identities, please let me know. Otherwise, we're going to move on to example 1. It says to simplify a trig expression, start by rewriting it in terms of one trig function or in terms of sine and cosine only. So what we're going to do is we want to go through and use our identities, that box on the top, to simplify the cosecant of theta times the secant of theta minus cotangent of theta. Your goal is to get it in terms of one trig function, and if you don't know what trig function to do it in, a lot of times you can go through and change stuff in terms of sines and cosines, and then simplify it from there. So we can look at cosecant, secant, and cotangent, and there's nothing really in our identities on the top that could get cosecant in terms of secant or vice versa, or the cotangent in terms of either one of those. So what we're going to do is we're going to go to using the sine and the cosine. So if we take a look at the cosecant of theta, in your reciprocal identities, the cosecant of theta is equal to 1 over the sine of theta. So again, we're looking to change each one of these functions into something with a sine or a cosine. And up on the top, you can see the cosecant is the same as 1 over the sine of theta. And then if we look for the secant of theta, if you look at the reciprocal identities, is 1 over the cosine. So I can multiply this by 1 over cosine of theta minus, and then if I want to get cotangent of theta in terms of sine and cosine, if I look at the quotient identities, I can see cotangent is cosine of theta over the sine of theta. And then from here, I'm going to go ahead and try to simplify as much as I can. I can multiply these two together. Doing that, I just get one fraction, which is 1 over sine theta cosine theta. And then I'm subtracting the cosine of theta over the sine of theta. And then what I want to do, if I'm subtracting, and this is where your fraction rules are going to come into play. You need to be very good with fractions in order to do the simplifying the right way. I need to subtract these fractions, and in order to subtract fractions, I need common denominators, which means I need the same thing here as I have here. Well, in this fraction, I have the denominator of sine and cosine, and in this fraction, I only have a sine. So in order to get common denominators, I would have to multiply this bottom by the cosine of theta. Well, if I multiply the bottom by cosine, I have to multiply the top by cosine as well, so that I'm just multiplying by a factor of 1. So what I get is 1 over sine theta cosine theta minus, on the top, cosine times cosine is cosine squared, over sine theta cosine theta. So now I have common denominators. And so what I can do is I can combine these into the same fraction. So now I'm looking at 1 minus cosine squared theta over sine theta cosine theta. And from here I'm looking to see, do I have any other sort of identities that I can use to start simplifying? If I have a fraction, most of the time I'm going to be looking at that numerator to see if there's anything else I can do. And this 1 minus cosine squared, anytime you have a 1 with a plus or a minus and you have a trig function that's squared, start taking a look at your Pythagorean identities. It doesn't mean you're going to have one, but there's a good chance that you will. And since I'm dealing with cosine squared, let's take a look at our Pythagorean identity with the sine and the cosine. I'm going to do that up here. That Pythagorean identity is sine squared plus cosine squared equal to 1. And I need to see, can I get this Pythagorean identity to be this 1 minus cosine squared? And I'm going to do this off to the side so it doesn't interrupt my work. Because as you're going through this, you need to make sure that you show me every single step along the way. And so if I want 1 minus cosine squared theta, I can subtract this over to the other side. And what I'm looking at is sine squared theta is equal to 1 minus cosine squared theta. And here's what I'm looking for. That 1 minus cosine squared theta is the same thing as just sine squared theta. So from here, I can change this to the sine squared theta over sine theta cosine theta. Now the other thing to realize is that this sine squared theta means that we're just multiplying a sine by a sine. So there's 2 sines basically up on the top. Well, if I have 2 on the top and I have 1 on the bottom, I can cancel out this sine with one of them on the top, leaving me with sine of theta over cosine theta. And I'm trying to get it down to one trig function if possible. Sine divided by cosine, using my reciprocal identities, is just the tangent of theta. So I can simplify this down to just tangent of theta. So again, you're looking for getting everything in terms of one trig function, if possible. Sometimes you won't be able to. But you want to use as many identities as you can to get it as simplified as possible. I'm also going to be looking for your work. I need to see the identities from one step to the next so I know how you got what you got. So your work is going to be worth more points than the actual answer itself. So do a good job of keeping your work organized so I know one step to the next. I'm going to do a separate video for the try this, so you can go ahead and try it and then go and click on the try this to see the video.